remember saying that I would never again work in CAR T because I just couldn't see how a company could develop the technology necessary to get past the bottlenecks we knew existed.
Really?
Well, yes. And so I have been offered jobs in other CAR T companies, and I have been offered consulting in other CAR T companies, and I have steadfastly said no, because every time I reviewed the technology, I saw the same limitations.
Welcome to NGBiLab, a podcast about innovators and disruptors who are creating the next generation of companies in Canadian life sciences. Hi, I'm Jim Wilson, and my guest today is Tanya Borsuk, who is CEO of Modulari-T Biosciences in Montreal, Quebec. The team at Modulari-T are working on what may be one of the most significant advances in cell therapy in decades. They've built the first second-generation in vivo CAR T system that works with the immune system rather than against it. They've also proven their technology across nearly 20 different target types, including cancers that previous generations of this technology simply could not touch. Tanya spent a number of years at Celgene, which became Bristol-Myers Squibb, where she watched CAR T technology hit its limits and swore she'd never work in that field again. Then she met the team at Modulari-T Biosciences, and the research they were doing changed her mind. Before we get to today's conversation, we'd like to let you know this podcast is part of the NGBi podcasts in support of Next Great Big Ideas, Canada's Life Sciences Summit. NGBi is a national networking event for Canada's life sciences community, and we invite you to attend. For details on this year's event, please go to nextgreatbigideas.com. This episode of NGBiLab was recorded in June 2026. Tanya, welcome to NGBiLab.
Thank you very much. It's great to be here, Jim.
It's great to have you. And let's jump in. I read that Modulari-T has developed a platform that expands the reach of cell therapies. And I would appreciate you explaining to your listeners, but mostly to me, what that means.
Well, so it means a few different things. And I think to better understand exactly the power of what we're developing at Modulari-T, I think it makes sense to sort of think a little bit about the history of cell therapies themselves and sort of how they were invented and where their uses were very profound and then where the limitations were. So cell therapy itself began as an academic lab construct many decades ago, back in the 1980s, as a matter of fact, where it was discovered that if they try to replicate the power of the immune system, then they can trick the immune system to attack cancer. Now, we see this evolving in a number of different ways in modern therapy, but back in the 1980s, that was something very new. And when it became a therapeutic event in the early to mid 2000s, we began to see that very thing in practice. So the use of the early generations of cell therapy were leading to cures in patients who had very little options. And notably, a patient called Emily Whitehead, actually, one of the first children cured by CAR T in CLL, chronic lymphocytic leukemia, was an absolute global phenomenon. So the hypothesis generated in the lab all those years ago became real. And companies like Novartis and Gilead and my company at the time, Celgene, which then became Bristol-Myers Squibb, really worked hard to innovate CAR T as a global therapeutic phenomenon, a new therapeutic phenomenon, to access patients that had no other options by using the immune system. The issue is there were many roadblocks along the way. We were never able to expand it to very many targets, very many diseases, and the original cell therapies were used outside of the body. So we needed to take patient cells who were very sick on often regimented timelines and then engineer it with our specific vectors to make it do what we wanted it to do and then put it back in the body. That process could sometimes take up to a month. Sometimes patients didn't have that time. It's very, very expensive. The average CAR T price was up to $500,000 or more per patient. So accessibility became obviously quite the problem. And then trying to expand beyond the hematological cancers into the solid tumors was almost impossible because it's very difficult to find a target in solid tumors that isn't also in normal disease. Last thing you want is to have your immune system attack your normal cells. Right. So there were a lot of limitations in the original technologies. People have been trying to surmount them with a number of different ways, with different cell types, with different vectors, with whatnot, but the same type of limitations survive. And that's even true in the modern versions, which are in vivo. So if you recall, Jim, the original versions had to be produced outside of the body. So then the concept became, what if we take those types of technology and put them inside of the body? Would that then make them more accessible, easier, and then just enhance its efficacy in other areas? And while that is proving to be true from the manufacturing and the ability to make them, and they're now more affordable along the lines of regular drugs, the same limitations persist because these companies are using the same technology by and large. So the way modularity is different is that it was incepted with the concept of what happens when we look at the technology that was invented in the 1980s and really has seen very little modification since then. But now, with our new understanding of the immune system, of what it looks like, of how it operates, redesign it from the ground up so that it works now more powerfully with the immune system in the modular way the immune system works instead of against it, and is truly designed to work inside of the body in the way the other technology doesn't do. What that allows us to do is we see new targets, we see new therapeutic windows, we see new diseases, and for the first time, can really work to take that life-altering technology that was invented all the way back then, but apply it to patients globally. And I think that's where the differences lie.
Okay. And forgive me, I don't have a science background, but are
No.
you disrupting existing technology or are you creating a new path? Like, is this new or is it improved?
Well, actually both. So that's a great question. So what we have is the first fully second generation in vivo CAR T system, or in vivo cell and gene therapy system. And what makes it both disruptive and new is that we're the first company that has two pieces of the platform. So the actual CAR itself, or the cell therapy mechanism itself, has been totally redesigned. But it is built off the back of the giants of the 1980s and Carl June's work in 1990s. And of course, that's in use today by the large pharmas that we, as I mentioned, we developed in the mid-2000s. It's been built off the knowledge of what went right with those technologies, but then expanded to address the elements that held it back, what went wrong in many ways. And then on the other hand, we've developed our own customized delivery vectors that are not off-the-shelf versions of ones that already existed in gene therapy, which our competitors use, but ones that were truly and thoughtfully designed to get around the issues of what the competitors do, but then merge together with the vector itself or with the construct itself to create the first fully working two-part system, which we feel will address a lot of the problems that even continue to hold the field back.
Okay, so are you and your team actually building the science on which this technology is based?
We are. So the science is originally innovated out of institutions in Montreal. So we're incredibly proud to be Canadian born and bred. And our founder and CSO, president and CSO, David Cottonor-White, in fact, is one of the inventors of the science itself. And once that was in-licensed into the company, the technology he helped innovate, the company has done a fabulous job in expanding on the intellectual property and the technology to continually innovate the science.
So what we're talking about is next generation cell therapies.
That's exactly it.
And again, for the uninitiated, you've done a great job of dumbing it down. Thank you. Are you focused on one or a number of different areas?
Well, also a good question. Now, as a small biotech, we're a little limited in what we can do today. So some of our goal is, of course, what we can do tomorrow as we grow as a company. But the beauty of the science that is being developed by Modularity, one of the key things that was disappointing, to be quite honest, as someone who was on the ground with the launch of the first two global CAR Ts as part of the Celgene BMS teams, one of the things that continually disappointed us is that no matter what there were two targets that worked, CD19 and BCMA, and no matter what we did to try to get new targets to work and address new patients, we were stymied. And the same thing happened with Novartis. The same thing happened with Gilead. And all of us really were in the same bucket on how to expand. The beauty of the science with Modularity is not only does it allow us to expand already into all sorts of different cancer tumor types, but by addressing one of the key issues that was present in all of the first generations of the technology, whether it was outside of the body or inside of the body, the toxicity. The toxicities associated with that type of therapy when you countermand the immune system can be very limiting. In fact, has actually led to patient deaths by some of our competitors. But one of the beauty of what we're developing is that the risk of that toxicity is much lower. And in addition, we have also developed a platform that allows us to integrate almost like gene therapy or not integrate, depending on the therapeutic indication, which also helps us control the toxicity. So thinking beyond cancer into other therapeutic areas like autoimmune, like inflammation and neurology. Can you imagine for the first time bringing a CAR T into neurology like Parkinson's, like Alzheimer's, to address these very difficult tumors? So in essence, the beauty of what we're developing allows us to look forward to the future of all sorts of different use cases for this technology for the first time.
Hi, it's Jim. When we come back, Tanya talks about how the company got started and why she initially thought she would be the last person to say yes to joining the team. Stay with us. I'm Jim Wilson, and you're listening to NGBiLab, Canada's Life Sciences Startup Podcast. Hi, it's Jim Wilson, and I'd like to take a moment to talk about the next Great Big Ideas Summit, which is coming this fall. If you are part of the Canadian life sciences community, NGBI is one of the key events you want to put in your calendar. The NGBI Summit is an independently organized, not-for-profit, national networking event that attracts innovators, investors, disruptors, academic entrepreneurs, industry suppliers, today's leaders, and startup founders from coast to coast who are quite likely many of tomorrow's industry leaders. The summit is an event that generates the kind of conversations that happen only when the right people are in the room. So if you are a member of the Canadian life sciences community, and frankly, even if you're not but you'd like to be, this event is for you, and we invite you to join us. For details on sponsorship and to purchase tickets, please go to nextgreatbigideas.com. Thanks so much. We look forward to having you join us. Let's get back to our conversation. Hey, welcome back. It's Jim Wilson, and my guest today is Tanya Borsuk, CEO of Modulari-T Biosciences in Montreal, Quebec. So are you in clinical trials at the moment?
No, we're still a younger biotech. So we are in preclinical, and because the technology has been almost entirely innovated in-house, it has taken, right? It takes its path in terms of proving, in terms of the different proof of concept. We have the absolute benefit of having proven our technology in almost 20 different target types now. And that includes hematology. It includes the targets that have already been done. It includes additional hematology indications that the other companies were never able to show, but then also already different solid tumor targets like HER2 and others where people have struggled to develop CAR T, and now also into the autoimmune inflammation. So we have built the proof of concept. We have proven out many of our hypotheses. And now it's time for us to adjust from a very early stage biotech into a preclinical and late preclinical stage biotech. And we will now be advancing towards the clinic. And that is the goal of our next fundraise, as well as some of our business development activity.
Okay. So the company was founded when exactly?
The company was founded in 2022. So in fact, it's quite young.
Yeah. And you're one of the co-founders?
No. So there are 3 co-founders in the company. I am very grateful to have joined them just over a year and a half ago to help them in the transition from an early stage biotech now into a larger company getting ready to transition into the ultimate clinical trial.
What got you to yes? What attracted you?
So this is very ironic, Jim. So after the heartbreak, to be quite honest, and going through a lot of the difficulties in the original iterations of cell therapy, I then did business development in pharmaceuticals for cell therapies and watched as the new technology emerged. And to be quite honest, was not bought in. So much so that I remember saying that I would never again work in CAR T because I just couldn't see how a company could develop the technology necessary to get past the bottlenecks we knew existed.
Really?
Oh, yes. And so I have been offered jobs in other CAR T companies, and I have been offered consulting in other CAR T companies, and I have steadfastly said no, because every time I reviewed the technology, I saw the same limitations. And in April of last year, in April 2025, I was introduced to this company via a well-known Canadian venture capital firm, Box One, and asked, we feel that your skill set as a consultant would be, very great with this company, and you can help them sort of, make the transition. And when I said, what is it that they do? They said CAR T, and I went, oh no. But my relationship with Box One is excellent. Their companies and portfolio companies are fantastic. And so I met with the team at Bloom Burton. There was an absolute clicking of personalities. And then as I worked with them over time to start getting prepared to meet with pharma, to prepare for business development on crafting the story, the data began to emerge. And you don't see this too often with very young companies, is every time I asked a question, do you have data that shows this? Expecting the answer to be no, I will be honest. The answer was yes. And more data began to emerge. The true story behind the company began to be very evident to me. But I'm a scientist. I'm all about the data. And the data that I began to see really began to convince me. Little by little, I sat there going, well, okay. Right? And as I worked with the team, we developed a natural rapport. And as I helped them interact with pharma companies and other companies, I watched the rapport and I watched the reaction. And deep down inside began with the glimmer, but then, all absolute raging hope of, we've really got something here. This is something that can change people's lives. And as a scientist, this is what you look for. This is what you look for in your career. Nothing is better than that feeling.
So they didn't have to convince you. You convinced yourself.
No, they didn't. They did amazing work, right? With the amount of data that such a young company had done on such a small amount of money. And the data, no matter however they tried it, new mechanisms, new cell types, whatnot, it all proved to be true to this point. And now nobody knows what happens in the future. But up until now, the proof of concept is very solid. It's very exciting. And together, I think we can create something very real and very meaningful and do things that other companies have not managed to do. But more importantly, the goal is to bring this type of therapy, which I know is curative because I've seen it in my time at pharma with the original iterations. It's to bring this type of therapy to patients worldwide who could not access it before. And there's nothing that gets you out of bed faster in the morning than an idea like that.
The company is based in Montreal.
It is.
And the co-founders, are they at University of Montreal, McGill?
No. So we're not a spin out. Well, we are a spin out of Université de Montréal. But at this point, the company is its wholly owned entity. All of the IP and technology resides within the company. We are a company of 8 people already, and we're looking to expand.
And who are you looking for those listeners who ears just went up, oh, really? You're hiring?
Well, TBD. So we are fundraising to expand the company and what have you. And when that is done, we'll begin to bring on board additional talent that will help us transition into that mid-stage preclinical company and then ultimately into a clinical stage company. So that requires various levels of expertise.
Right. So how much money are you looking to raise at the moment?
So we've just launched our seed raise of $15 million. And that, as I've mentioned, is to get our lead programs into human, where the proof is in the pudding, as they say, as well as advance some of our up and coming 2nd and 3rd generation targets into DC and then prepare them ultimately for human studies as well.
I'm going to go back a bit here. Listening to how the company came about, the one thing that I was thinking is, was it a business that kind of serendipitously evolved out of lab research, or was it a predetermined business idea that the lab research backed up?
Well, I can't comment on exactly when the decision was made to spin it out into a company because I wasn't there at that time. And my colleague David would have to talk about that because he was the original founder. What I can say, though, is that the science was born out of the desire to change the prior work. This I know. The science was born in order to advance this technology. Now, I think once the proof of concept elements began to appear on exactly how differentiated that really was, David and co-founders decided to make a go of this as a business, rightfully so, because this is exactly the type of technology that we need in general in the biotech landscape. But in terms of Canada, right, it's just a beautiful exposition on the type of science done in the Canadian institutions that don't always see the light of day in terms of companies, either via lack of funding or also via just that it's very difficult to be an entrepreneur. And so, I commend my colleagues with the vision and the wherewithal to take this and run with it and make it, a thing, because I think I can comfortably say we are Canada's really only truly purposely built from the ground up in vivo CAR T company. And it is one of the most exciting fields today in biotech. And we have a chance to make this Canadian technology very differentiated.
So I get this is to help patients, but is the target client like a big pharma? This is to commercialize and have an exit strategy and then perhaps go do it again?
Well, that's never a bad thing. But I think, let's say a little bit all of the above. So the wonderful thing about the platforms is the fact that we have two. And as a global business development I'm not going to call myself expert, but an experienced global business development person who's done $9 billion in business development transactions, both on the pharma side.
I'll call you an expert.
And there's always people that know more than we do in life. So let's call myself experienced. $9 billion on both pharma as well as the biotech side. So we say buy side and sell side business development. This is the type of thing that pharma and frankly, other biotechs need. The beauty of what my colleagues have created at Modularity and how we together are advancing the platforms is that we have two. And not only do they work together to create the first truly second generation system, they can be uncoupled and work with other people's technology. And so, of course, we've been quite busy with business development discussions with pharma who either already have their own CAR T platforms and need to move to next generation technology, or ones that didn't play in the original technology yet because they didn't believe what they saw. And so we're very gratified that we're in late stage discussions with our very first business development deal with a global top 5 pharma. We hope to close that within the next month or so. And this is where we now start applying our technology, not only for ourselves, but then for companies like these global pharmaceutical companies and biotechs, and help enable even that much more paths to the patient.
Hey, it's Jim again. When we come back, Tanya talks about what it takes for a new biotech company to survive and the advice she would give to anyone thinking about becoming an entrepreneur in life sciences. Stay tuned. I'm Jim Wilson, and you're listening to NGBiLab. Listeners of the NGBI podcasts know the goal of this podcast, NGBiLab, is to shine a light on up-and-coming startups in Canadian life sciences and the people and stories behind them. If you like what we're doing, we have a small favor to ask. Please tell your friends about us and promote us on social. You can use the hashtags NGBiLab, NGBI Podcasts, and NGBI Summit. We appreciate your support and help in getting the word out about what we're doing. On that note, if you are a startup founder who is working on one of the next great big ideas in Canadian life sciences, please let us know what you're doing. My contact information is at the end of today's show, and we look forward to hearing from you. Thanks so much for listening. Let's get back to our conversation. Welcome back. It's Jim Wilson, and my guest today is Tanya Borsuk, CEO of Modulari-T Biosciences in Montreal, Quebec. So what has been your biggest win so far?
Well, as a small company, I'm going to say the biggest win is that they've managed to stay alive for this many years in the worst biotech industry that's ever been. And
that's experience talking.
Oh, indeed. It's a hardworking team. They're scrappy. They know how to be capital efficient. They know how to do the work that matters. And I think that's one of the biggest wins. I think our second win is one of the hardest things for young biotechs to achieve, and we're in the process of that now, is the transition from the startup company into something that is a full-fledged preclinical biotech. And biotechs all have different stages, just like our children. And so we go from the young stage into sort of the middle stage, and then, look to prepare to become the clinical stage, which is one of the most difficult transitions. So I think the first win is we're still here and we're creating great things with our science. And where our win is currently emerging now is we are solidly making that transition to the second stage to really enable this technology to get into patients.
You've got a lot of deep experience and broad experience in life sciences, from being a C-suite leader, an advisor, an investor. Is there any advice you would give to listeners listeners who are thinking about becoming entrepreneurs in this sector?
Yes, I would. And, this was advice, frankly, given to me by someone I consider very much a mentor. Actually, it's at another Canadian biotech. It's Clarissa Desjardins from Congruence Therapeutics, who was my boss and, is just a powerhouse of entrepreneurship within, the
Absolutely.
Canadian system, but frankly, globally. One of the greatest pieces of advice she ever gave to me was, you cannot be afraid to fail. And let me tell you, I'm a Virgo, very anal about data and science. And I'm not going to lie and say that I have never been afraid to fail. Far from that. But watching her adapt to that mentality and watching it in real time, I think changed something in me. And she's right. If we're going to we can't sit on the sidelines and say, if only all of this technology, if only. When the opportunity presents itself to make a difference, to start a company that you truly believe in that will make a difference, such as Clarissa has done 4 times and others within our Canadian ecosystem repeatedly do. We cannot be afraid to fail. And you never know, what the upside is, but you'll never know if you don't explore it. And I think, the same is true for my colleagues at Modularity. They did one of the hardest things, tackling cell therapy, and they were not afraid to fail. They did it despite the difficulties, the historical difficulties in this realm. So I think the advice that I've had to learn along the way and everyone else has had to learn is it's true, right? Fear of failure stops patient advancement, and the patients are waiting for us to help them. We cannot be afraid to fail.
It's great advice. Thank you. Again, I'm going to back up a bit here. It sounds like the sandbox you're playing in, it doesn't have a whole lot of company. Are you the only people here?
No. So, we're the only people with the technology that we have. We largely consider ourselves the only people with the first true second generation system because of the differences in the technology.
Thinking,
Yes. But there's all sorts of companies that are within the realm of cell therapy that are advancing various different forms of technology. And the wonderful thing about this is that while they are competition, frankly, we root for them all because everybody's win is that much closer to the patient, and all of us can learn from one another by all of our wins. And there's lots of patient need to go around. There's lots of realm and different ways technology can be expanded. So while we are the only ones that are doing what we're doing to our knowledge, there are many others that have various forms that will likely be applicable in different areas. And we truly root for everyone because everyone's success is our success as well.
Yeah, success is a team sport.
It is.
You were born in Canada, but you live in New Jersey now, correct?
Yes, that's correct.
And we were chatting earlier before we started recording that you did your PhD at Rutgers.
I did. I'm a proud Rutgers alum, but then also a proud Queen's University graduate.
Where I'm going with this is I'm wondering if your perspective might be different from the typical entrepreneur in Canada.
Well, I am incredibly blessed to be on various boards and to have helped and interacted with many young companies in Canada. So I'm on the board of the Toronto Innovation Acceleration Partners, TAP, as well as subboard Lab 150. And it is our mission to create and drive novel Canadian companies. So, it feels like every day I meet a new, exciting Canadian company and their entrepreneurs who are, fighting the good fight and taking that novel Canadian technology and making something new. Does my mentality or experience change, or is it different than theirs? No, the entrepreneurial spirit is the entrepreneurial spirit, and the Canadian entrepreneurial spirit is the Canadian entrepreneurial spirit. Wherever I reside, I'm still Canadian. And so I see myself echoed in all of these various companies. I think the difference is that expertise can change in different regions. And I've been quite blessed to call myself educated within the American and the global biotech and pharmaceutical industries via my work here in the United States, but also in Europe as well as Asia. So I have seen a lot. And I think that perspective does very much help because it has always been my perspective that a company exists and succeeds based on its ability to translate the intersection of science and business. You can have the most wonderful science, but if your business acumen or your understanding of how to develop that and get it to the patient is lacking, then you will have difficulties. And you can be a phenomenal business person. But in my heart, if you're not developing something new that can change lives, then why? And it's always been my mission to be in the intersection of both. And so I think because of the expertise that's been afforded to me, I do bring a bit of a different perspective. But at its heart is always the Canadian entrepreneurial sense. So there I am aligned with my Canadian brethren.
Yeah, and I'm not saying this to make you feel good. We are so fortunate to have you on the team. And thank you so much for your time today. It's been a pleasure learning about what it is you're doing, and I'm looking forward to future announcements.
No, thank you, Jim. This has been a delight. It's always a pleasure to watch your podcasts, and you have some of my many esteemed colleagues interviewed in the past. I've loved watching their interviews, so I'm very honored to be given the chance to participate.
Oh, that's very kind. Thanks. That was Tanya Borsuk, who is CEO of Modulari-T Biosciences in Montreal. To learn more about the work Tanya and her team are doing, please go to modularity.bio. That's MODULARIT.bio. You can also follow Tanya on social at Tanya-E-Borsuk-PhD. And Borsuk is Borsuk. If you'd like to learn about this podcast, please visit nextgreatbigideas.com. You can also follow us on social at NGBI Podcasts. If you'd like to learn about who I am and what I do when I'm not hosting podcasts, please visit jim-wilson.ca and laboccupier.com. You can also follow me on social at laboccupier. This episode of NGBI Lab was researched by Xenia Pinto and edited by No Limit Marketing. If you'd like to get in touch, email is best. My address is jwilson@Leonard, that's LENNARD.com. You've been listening to NGBI Lab, Canada's Life Sciences Startup Podcast. Thanks so much. See you next time.